Hi there, I'm Luke McKinney, Prep 101's Physics 101 instructor, and in this video we'll be looking at how to deal with vectors.
Vectors, we know, have a size and a direction. And so this direction is always represented by a straight line arrow. Now, if we want to add or subtract or deal with these, then there's two main ways of doing it. The first is graphical, which we'll have a quick look at to make sure we're comfortable with it, but we'll be mainly using mathematical when we're doing any physics. Now, graphical is if we have two vectors, A and B, and we want to add them to see the result, well, we just literally do them one after the other. If I start here, A says go up and to the right, B says go up and to the left. So if I do one after the other, the result is up and a bit less to the right. So that's our new vector, which we'll call C. Another way of increasing how far you go is if we just multiply a vector by a scalar. And if we're doing 3A, well, that just means we do A again, and A again 3 times. And so we get the result, as you'd expect, 3 times as long as A in the same direction. Now, what if we want to subtract something? Well, we have our two vectors, A and B, and we can use the fact that in physics, plus and minus are just directions. We've already seen this with our axes. We know that plus x is to the right, so minus x is to the left. Plus y is up, so minus y on that axis is down. And likewise, if we have b up and to the left, minus b is exactly the same size along the same axis, but pointing the other way round. And then to subtract, we can just say a plus b. Well, we know how to do that. But a minus b is a plus minus b. And so we draw a plus minus b, and then we get the result of a minus b. There's also a sort of quick novelty way to do that as well if you're interested. You can get a minus b just by drawing a and b from the same point, and then a minus b, you start from b and go to the end of a. And that will also give you the vector a minus b. Not a tool you'll ever desperately need, but sometimes people see it, and if I don't mention it, they think, what about that one? Yep, it works perfectly fine. The other and much more useful overall way of doing things is with math, because in physics we do lots of things with math. If you're bracing yourself at that idea, fair enough, a lot of people are. You've got my sympathy, but you've also got my advice. Just let go of that feeling of it being hard, because it's quite a clear tool we'll always be using in this physics here, and with a bit of practice it gets very handy. Now, the way we use the math in order to add vectors, we use the fact that we can separate any vector up into x and y components. For example, our vector a there, well, it's at some angle to the horizontal, and we can break that up into an x component, which is the length a times the cosine of the angle, because that's the side adjacent to the angle. And the other side of this right angle triangle is the vertical component, which is a times the sine of the angle, which is the opposite side. And once we have these components, we can then put together any vector we want. The size of the vector is just the square root, sum of the squares of the other two sides, horizontal and vertical. That's our friend Pythagoras. And you can find the angle from the inverse tan of the opposite side over the adjacent. And this can be used to add and subtract any number of vectors simultaneously, way faster and more powerful than fiddling around with drawing. How do you do that? Well, if you want to find C is A plus B, what you do is you break up A into its X and Y components, like we just saw, B into its X and Y components. And remember, these might be plus or minus, because in physics, plus and minus are just directions. And then once you have numbers, you can just add them directly, which is way faster than messing around with drawing, and more generally useful in all sorts of different parts of the course. And then once you have the components, you put them back together to find the magnitude by Pythagoras and the angle from the inverse tan. Now visually, what's going on there? Well, we had A, so we broke that up into a horizontal component and a vertical component. We had B, which we broke up into a horizontal and vertical. Excuse me there. So when we add them together, we find the components for X and Y of C. So onto a new page. Never try to cram things into the bottom of a page. It always gets very muddy. So then we found we had a shorter X component, a large Y component, and we found C, just as before. But you don't actually have to do all that fiddly drawing when you're using math. And once you've got this mathematical idea of breaking up vectors into components, X and Y, and then just doing math with them, you'll find this covers a huge swathe of the course, things like projectile, forces, all of that jazz.
I hope that was useful. There's plenty more videos in the playlist, but what's even more useful is lots of exam examples and exam specific advice. And that's what we do in the prep sessions. So join the Prep 101 Study Hub Facebook page to find out when those go on, and many of them are even free, so you definitely don't want to miss those. Hope to see you there.